All right, we are here with 7th grade 6.2.2, and it's titled, How Do I Know That It Is Correct? So yesterday we did a lot of simplifying expressions and finding solutions for those equations, and we were introduced to the equation mat, and we're going to be working more with that today. So this is called, How Do I Know That It Is Correct? Checking Solutions and the Distributive Property. And I'm going to read the introduction. Sometimes, a lot can depend on the solution of a problem. For example, when businesses calculate the cost of packaging and shipping a product, they need to come up with an accurate value. If they miscalculate by only 1 cent per package, but ship 1 million packages per year, this small calculation could be costly. Solving a problem is one challenge. However, once it is solved, it's important to have ways to know whether the solution you found is correct. In this lesson, you'll be solving equations and finding ways to determine whether your solution makes the equation true. And we're getting through, I believe, 660 through 664. And we're going to start with 660. 6-60 reads, Chen's sister made this riddle for him to solve. I'm thinking of a number. If you add 2 to the number and then triple it, you get 9. So it wants us for A to build the equation on an equation mat using algebra tiles. What are 2 ways that Chen could write this equation? So if you have the E tool, you can use the E tool. I'm going to draw it because I kind of like drawing it physically. So I'm going to draw an equation mat, and in the equation mat there are double lines in the middle, and those double lines signify that this side is equal to this side. So I'm also going to put an equal sign so we remember. Okay, so here is the riddle. Thinking of a number, anytime we think of a number, we're going to use a variable, and we usually use x. That's usually what we use. So we're going to think about x as our number. If we add 2 to x and then triple all of that, you get 9. So this is when distributive property comes back in. And remember, distributive property is when you have like a number on the outside of parentheses and you have to distribute that number to everything inside the parentheses. So let's build it first. So let's think of our number. Our number is x, so I'm going to draw an X tile, and I'm not going to shade in anything today because we're working with just positive numbers, for this problem at least. Okay, so here's our number, X. If you add 2 to the number and then triple it. So what I did, here's what I did. So I made 2 groups, sorry, let me rephrase that. I started with X plus 2, because that means if you add 2 to our number, that's our first part of the number riddle, then tripling this group means you multiply by 3. So I'm going to make 2 more groups of x plus 2. So there we have our 3 groups of x plus 2. And the last part of the riddle is that you get 9. So I'm going to put 9 units on this side because this is what equals. That's the product of our equation on this side. You will get that. Okay, so now, not done with A yet because it does ask for 2 ways that you could write this equation. So I'm going to write it, I wrote it 2 different ways. I wrote it as 3 parentheses x plus 2 equals 9. This just means that I have 3 groups of x plus 2, and I do because I see them. 1 group, 2 group, 3 group. And the other way you could also write it is to actually distribute that 3 to everything inside the parentheses. So if I did that, that 3 needs to multiply to the x, and it needs to multiply to the 2. Because we're distributing it to each term in the parentheses. So 3 times x just gives us 3x. 3 times 2 just gives us 6. set it equal to 9. So those are the two ways that you could write the equation. I actually found a different way that you could have done it, and if you did it this way, that's fine too. It's kind of the longer way. I did x plus 2 plus x plus 2 plus x plus 2 equals 9. Still the same thing. We've got 3 x's, and we've got 6 ones on this side, so that could also be an alternative way you could have written it. Okay, I'm not really happy right now because I just realized that it cut out like a lot of the lesson. So I'm gonna try and pick back up where it left off. Now I know how all those YouTubers feel when they're like, sorry, my video cut off, now I have to refilm everything. Okay, anyways, so this is kind of where we were at. And if I repeat something that I've already said, I'm sorry. But we're gonna solve this equation by doing the moves for simplifying each side of the mat. Okay. Just gotta roll with the punches. Okay. What I notice is I can remove ones from this side and match them up from this side. So I'm gonna take a group of 2 here and a group of 2 here, and those can leave. A group of 2 can leave. Last group of 2 can leave. And I'm left with what am I looking at? 3 x's equals 3, because that's all I'm left with on either side. Lastly, we are going to want to get this x all by itself, so we want to divide both sides by 3, because when we do that, we're left with a 1, and that's what we want on this side, and we're actually left with a 1 on that side. So the answer that we have come up with is x equals 1, and it got really kind of dark all of a sudden outside, but I guess it doesn't affect the whiteboard. So that's part B, and then part C says, when Chen told his sister the mystery number in the riddle was x equals 1, she said he was wrong. Chen was sure that he had figured out the correct number. Find a way to justify that we have the correct solution of x equals 1. Justify means to prove that x equals 1. And this is how you prove it. We are going to plug x equals 1 back into our original equation. So let's do that. 3 times 1, whoa, those are supposed to be parentheses, plus 6 equals 9. 3 times 1 is 3, plus 6 equals 9. 3 plus 6 is 9. 9 equals 9. Chen's sister is wrong. Chen's right. X equals 1 is the solution. Yay! Okay, moving on. I feel like deja vu. I've done this all before. 661. I did this so good the first time. Okay, 661 is, we're solving a new equation, which is 4 times x plus 3 equals 8. Okay, there's 4 parts of this. It doesn't say A, B, C, or D, but it has bullet points. So the first bullet point says to build the equation with an equation mat. That's what we'll do first. Our equation mat has 2 double lines, which just means equals. And we have, on this side, we have 4 groups of x plus 3, which is what we're going to draw. You can do it on the E tool if you so choose. Need 4 groups of these. Make sure I make room for them. And we're left with 8 units on this side. Okay, that was the first bullet point. Ugh. Now we're going to simplify using our moves. And the move that I can see that we can do is we can remove, sorry, there's like a hair on my face. There we go. We can remove ones from this side that match up with ones on this side. So let's start removing groups of 3. There's a group of 3 and there's a group of 3. Another one, another one. Now I don't have any more groups of 3 that I can remove, but I can remove 2 more because I have 2 left on that side. So now my equation is Here's an x, there's an x, there's an x, there's an x. I'm left with 4x plus 1, 2, 3, 4 equals 0. All right, some of you might know what the solution is already just by looking at this, and that's great, but I'm going to go through it algebraically. So I want x all alone on this side, so I want to get rid of this 4, and to get rid of it, we subtract 4, because we want to make it 0, so that makes 0. 4x equals 0 minus 4, which gives us negative 4. We want x all by itself, so we divide by 4, divide by 4. We're left with x equals negative 4 divided by 4 is negative 1. So there is our solution for 661. Let's make sure it's still recording. And it is. This time, jeez. Okay, now we're getting caught up to where I figured out that it was not recording. 662. Okay. Part A for 662 is just us plugging the negative 1 back into our original equation for 661. And this was our original equation. Now we're going to plug our solution, which we found was negative 1. We're going to plug that negative 1 in for x. Okay, let's do what's in the parentheses. Negative 1 plus 3 is 2. So 4 times 2 is 8. 4 times 2 is 8. 8 equals 8. So we have double checked and we have confirmed that negative 1 is the solution for this equation. Okay, I think this is where I left off, which is actually a good spot to leave off on because I think it got a lot of me just writing stuff down. So moving on to B, I'm not going to really write stuff down because it's going to go to the next clip. When Kelly and Madison compare their solutions for this equation, Kelly got a solution of x equals 2 and Madison got a solution of x equals 1. So to decide if the solutions were correct, the girls decided to check their answers to see if they made the expressions equal. And this is actually in your book, and it's a table, and I'll cut to it now. Hopefully it works. I really hope that it didn't turn off right in the middle because that would make me really sad, but we're picking up on 662B and I have it all written down now. Maybe it's because I'm running out of room. Okay, well, I'll try to be fast then, but not too fast. Okay, so we're gonna finish their work here. So we're gonna multiply 2 times 2, which is 4, minus 7, which equals negative 2 times 2, which is negative 4, plus 1. So that would give us 4 minus 7 is negative 3, and negative 4 plus 1 is negative 3. So that looks like Kelly's works. Let's see if Madison's works. So 2 times negative 1 is negative 2, minus 7 equals negative 2 times negative 1 is positive 2, plus 1, and we're left with negative 2 minus 7, which gives us a negative 9, and 2 plus 1 is 3. And that is not equal. So that means that Kelly is the winner of this equation. So part C says, when checking, Kelly ended up with negative 3 equals negative 3. Does this mean her answer is correct or incorrect? And if it is correct, does this mean the solution is x equals negative 3? Or is this the solution? So it's kind of trying to get you to figure out, well, if you're checking your answer, be careful that you don't, when you come all the way down to your final solution on each side, that you don't put that, oh, I did all my work and it looks like negative 3 is equal to negative 3, so x must equal negative 3. No. You have to remember that we started with x equals 2, and we plugged 2 in for the x. So make sure, that's what part C says. Negative 3 just shows that our equations are equal when we plug in the solution of 2. So the solution, x equals 2, is our actual answer, not negative 3. And part D, I keep making sure that my Camera's still going because it wasn't going. Okay, so part D for this problem says to go back to 661 and show how to check your solution, which we already did, but let's do it again. Just real quick. This was our equation from 661. Our solution we found was x equals -1. Let's plug in that -1 for x, or we have 4, parentheses, -1 plus 3 equals 8. -1 plus 3 is 2. 4 times 2 is 8. 8 equals 8, and we are good to go. So that's 662. Let me check if it's still recording, please. Yay! Okay. All right, 663. Second to last problem today. Oh, okay. Kelly solved the equation for parentheses x plus 3 equals 8 from the last problem. Her work is shown in your book at the right, and it says if 4 times x plus 3 equals 8. Oh, I'm gonna write down her stuff real quick, as quick as I can, because this is how she did it. Whoa! Bailey's snoring. I don't know what she's doing. She is sleeping like a baby. Okay, this is what she did, and this is in your book. So it looks like she went from this first step, so this is her step 1, step 2, step 3, step 4, step 5. So she started with the original equation, and then we come down to step 2, and what I noticed is that she got rid of the 4, and I'm wondering how she got rid of the 4. Oh, and the 8 became a 2. So if you think about it, it seems like she divided that 4 from both sides. So let's see. If she divided that 4, she would be left with x plus 3 equals 2. I'm pretty sure that's what she did. So yes, x plus 3 does have to equal 2 in this problem because she divided the 4 out, and she divided this side by this side because you have to do the same thing to both sides. So x plus 3 has to equal 2, and that's what part A is asking. Part B says, what did Kelly do to remove the 3 unit tiles from the left side of her equation? Does this move affect the equality? So it looks like to me, for this step 3, she is subtracting 3 units from both sides. So she's matching up the 3. She wants to get rid of this 3 from both sides. And she's left with, okay, I see what she did. She did this first. So she did 2 plus -3 is -1, but she kept this one down here to show us that we're about to make a 0. So here's our 4th step. She's left with this x plus 3 plus -3, and we know that 3 plus -3 gives us a 0. So bring down that x and bring down that -1, and you're left with x equals -1. And to answer part B, did subtracting 3 from both sides affect the equality of the equation? And no, it did not, because you have to do what you do to one side, you have to do to the other, or you're going to sacrifice, or you're going to compromise the equality. between the both sides of the equation. Okay, that one was a little rough to explain. Let's move on to C. Here's what I'm gonna leave. I'm gonna leave that, I'm gonna leave that, I'm gonna take away that, I'm gonna take away these things. I don't really know if that's helping much, but we're moving on to C, and it says, if Kelly were solving a new equation, I'm getting rid of it. I'm just going to get rid of it. Okay, her new equation, 3 times x minus 5 equals 9. So it looks like she did in the last part of this problem, remember she took away that 4. She divided 4 from this 4 and from this 8, and she was left with x plus 3 equals 2. So now I'm looking at this one and I'm saying to myself, well, I can get rid of this 3 by dividing that out because it evenly goes into 9. And we would be left with 3 divided by 3 is 1, so don't bother with it. X minus 5, and then 9 divided by 3 is just 3. So that would probably be her first step. After that step, I'm thinking she would want to get x by itself, so she would add 5 units to each side to get rid of this negative 5 and make it a 0. So you're left with 3 plus 5 is 8, x equals 8 as her solution. So that's how she does it. And it works well if you have two numbers that are divisible by each other. One can divide into the other evenly, whole numbers with whole numbers. Okay, that was 663, and we have one more problem. $664. Okay, 664 is kind of a long one. And I'm gonna try and get through it as quickly as possible because there's 6 parts to it. And if you don't want to watch the whole thing, just maybe watch the first 2 and then like try the rest on your own because there's a lot here. All right, let's do A. So it looks like 4 times x plus 1 equals negative x. Whoa, that is not what it is. Plus 1 plus negative x equals 10 plus x. Okay, the first thing I'm looking at is, okay, I'm gonna distribute the 4 to everything in the parentheses before I do anything else. So I'm gonna do that first. So 4 times x is 4x. 4 times 1 is 4. Now I'm gonna add everything again. The next thing I did is I combined like terms on this side because there's a couple terms that we can combine. So this 4x and this plus negative x can be combined because they're like terms. So 4x minus x is 3x. I'm gonna get rid of that, And then 4 plus 1 needs to be combined to 5. So that's done. Equals 10 plus x. The next thing I did is I needed to get x by itself on one side and the 1's on the other side. So I wanted to bring this x to this side, and in order to make this positive x a 0, I subtract an x. And that becomes 0. 3x minus an x is 2x plus 5 and equals 10. The next thing I did, again, I need x by itself, and it's not by itself yet. It's still got this 5. So I want to get rid of a positive 5 by minusing a 5 from both sides. And you'll notice it's not going to be a nice whole number at the end. X by itself, we need to divide the 2 by both sides. and we're left with x equals 5/2 or 2.5. Either works. All right, moving along. Part B. Let me make sure it's recording. Yes, it is. Okay. Part B says -1 plus 2x minus x equals x minus 8 plus -x. Whew. All right, first thing I did, I combined all the like terms on each side of the equation. So I knew 2x minus x needed to be dealt with. So I brought the -1 down because I can't do anything with it yet. 2x minus an x just leaves us with 1x. And then x plus a -x gives us 0. Oh, bye-bye. So that would just be a -8 on that side. Now, I still got this x and this -1 together, so I need to get rid of the -1 by adding a 1 to both sides. So that's 0. Bring down the x. I'm left with -8 plus 1, which is equal to -7. So it's a lot of combining like terms and noticing what you can combine together and then what you can start removing from each side. Let's do part C. Okay, we got some distributive property. 5 plus 2 times x minus 4 equals 4x plus 7. First thing I do before I do anything is I distribute that 2 to everything inside the parentheses. So I'm left with 5 plus 2x. 2 times -4 is -8. And then rewrite everything after. I have like terms that I can combine on this side, the 5 and the -8. So 5 minus 8 gives us -3. And the next thing I did was, okay, I subtracted a 2x from both sides because I want this 2x gone. And I'm left with -3 equals 2x plus 7. Now the reason I didn't bring this 4x over is that I want x to be positive because you can, but you want x at the very end to be a positive x. You don't want x to be negative. So you could do it either way. You could bring the 4 over here if you wanted to, but just for my brain, I like to do it this way. So I subtracted 2 from here, 2 from here. This is what I'm left with. And then I need to get x by itself over here, so I minused 7. And I'm left with -3 minus 7, which is -10. Which, -10 equals 2x. I need to get x all by himself. So I divide the 2 to both sides. -10 divided by 2 is -5. And that is just x. X equals -5. And it's okay if the x is on the right side. That is okay. All right, we got 3 more and then we're done. Whoops, I erased the problem number. 664. Let's rewrite it. Okay, part D. 9 minus 3x equals 1 plus x. Okay, I can't combine any like terms on either side. So now I need to just start transferring stuff from one side to the other. So I brought this 3x over. Bailey, oh my gosh, are you kidding me? She just like farted. Okay, -3x, to get rid of the -3x, I add a 3x. That becomes 0. I'm left with 9 equals 1, and that would be 4x because I have an x plus 3x. And then I want to get 4x by itself, and I have a positive 1 here. So I subtract 1 to make it 0. Subtract it from both sides. I'm left with 8 equals 4x. Last step, get rid of this 4 by dividing it by both sides. 8 divided by 4 is 2. X is by itself on that side, and that is our solution. X equals 2, or 2 equals X, for part D. All right, part E. Part E, 3x plus 3 minus x plus 2 equals x plus 5. Okay, for this one, I see I can combine some like terms on this side. So I have a 3x and I have a negative x, so I'm going to subtract that. I'm going to subtract them. 3x minus x is 2x. 3 plus 2 is 5. And x plus 5 is the same. Let's subtract this 5 first. Ooh, and you'll notice that becomes 0 and that becomes 0. So we're left with 2x equals x. Is that what I did? That is not what I did. This is what I actually did. I don't know why I'm doing it this way. I did 2x plus 5 equals x plus 5. And I got rid of the x over here and the x over here, and I was left with 1x plus 5, which equals 5. And then I subtracted 5 from both sides, and I got x equals 0. I don't know what I was thinking. It's probably from the craziness of being self-isolated. All right. Sorry about that. That even woke Bailey up. All right, part F, last one. You can do this. 4 equals 3 times 2x plus 1 minus 11. First things first. Distribute. 3 times 2x is 6x. 3 times 1 is 3 minus 11. Let's combine this 3 and 11. So 4 equals 6x, and that's plus a negative 8. Could also put minus 8, same thing. I want x all by itself, so I want to get rid of this plus a negative 8. So I'm going to add 8 to make it 0. Left with 4 plus 8 is 12, equals 6x. I want to get x all by itself, so I divide by 6. I'm left with 2 equals x, and that is the end of this lesson. And that was quite a doozy. Okay, now I think Bailey needs to be a part of this. Whoops, sorry. Here's my stand that my dad made for me, and he taped it to the chair. It's great. And here's Bailey. Hi, Bailey. Were you snoring? There's no more snoring. I can't have you snoring when I do my lessons. It's okay, Bailey. I forgive you. Okay, see you later.